Hello everyone, this is the first video of Calculus 1. We're going to start with the most important concept in calculus, which is limits. One of the most important motivations for using calculus is tangent lines. Tangent came from a word in Latin that means touching. So in this case, it is a line that intersects a circle only once. But is it possible to define this line mathematically? Let's take a look at a parabola, which is defined by the function of x equal to x squared. If we were to find the slope, or the tangent line at point P11 here, suppose we have another point Q anywhere along this line, which corresponds to x and x squared. The slope between the line P and Q will be defined by this equation right here. Notice that if we move point Q here closer and closer to point P, the slope will get closer and closer to be the tangent line of these two. Notice here that if we plug in the value of x, the slope will get closer and closer to a certain value. This is how we can write it mathematically. Limit of x as x approaches 1 of x squared minus 1 over x minus 1. And by looking at the table, we can conclude that this equals to 2. Here's another example of using limits. We have position s as a function of time t. They're asking us how to find the velocity v when t equals 5. We know that the average velocity is the change in position divided by the change in time. In this case, it is 49t2 squared minus t1 squared divided by t2 minus t1. If you plug in the value of t1 and t2, making the interval closer and closer to 5, you'll notice that the value of average velocity gets closer and closer to 49. We can write this down as the limit of t2 approaching t1 from the positive side, while t1 equals 5 of the average velocity function equals to 49. Now we can conclude that the instantaneous velocity at t equals 5 is 49. Now let's define limits mathematically. We have the limit of x approaching a of the function of x is equal to L. The definition of limit is if you think of any number epsilon stretching from the limit L, you can always find a number delta that stretches from a. So even if epsilon gets smaller and smaller, you can always find delta that confines the value of x. An easy way to write this down is if you think of the number epsilon and delta that is greater than 0, such that the distance between x and a is less than delta, that causes the distance between f of x and L to be less than epsilon. Then we conclude that the limit is true. The formal way to write this down is for all epsilon greater than 0, there exists a number delta greater than 0 such that the distance between f of x and L is less than epsilon when the distance between x and a is less than delta. Then we conclude that the limit of x approaches a of f of x is equal to L. This is called the Epsilon-Delta definition. Another way to picture this is if we take a look at the domain and range of this function. X relates with f of x, and a relates to L, the limit. We see here that as x approaches a and fx approaches L, the distance between them can always be confined by the value epsilon and delta.